Okay, let's talk about what we went over in class today. It was about graphing these rational functions. So we're going to go ahead and dive right in. Share screen. So I'm going to do one of the examples from the practice in class. So here's what we got. Number 5, y equals 2x squared over x squared minus 6x. So first thing we're going to do is like we did all last week. We're going to turn this into factored form. So up top, it's going to be 2 times x. And down below, it's x times x minus 6. If you're ever unsure, you just go to Desmos, you type it in, you figure out where it crosses the x-axis. So there's my factored form. We worry about the denominator first. So in the denominator, x equals 0 and x equals 6 makes the denominator 0. So there's going to be my holes or my vertical asymptotes. I check and see what happens when I plug it into the numerator. So when I put 0 into the numerator, that makes the numerator 0. So that tells me x equals 0 as a whole. X equals 6, when I plug it into the numerator, is not 0. So that means x equals 6 is a vertical asymptote. Now, today we entered a new thing with the domain. And what the domain is it's the values that make the denominator 0. So basically these. We got to say that the domain can be any numbers except 0 and except 6. So x doesn't equal 0, x doesn't equal 6. Those are our domains. That's a new piece, but it's basically whatever these pieces are here. Now, for x-intercept, what makes the numerator 0? In this case, 0 makes the numerator 0. But since we already used it for our whole, we don't have any x-intercepts. So again, a little bit of a review, what we quizzed on today. Next thing we're going to look at is y-intercept and horizontal asymptote. So horizontal asymptote is determined by the degree of the numerator, degree of the denominator. So in this case, the numerator's degree is 1, the denominator's degree is 1. So that tells me that the ratio of those y equals the leading coefficients, 2 over 1. That tells me that the horizontal asymptote is at y equals 2. And last, we're going to do the y-intercept. And the y-intercept is going to be the ratio of the constant terms. In this case, there are no constant terms. They're both 0. So since they're both 0, that tells me that there's actually no y-intercepts. We're not going to worry about slant asymptote. That's not something we're covering. So now, here's how we graph it. We start by graphing any intercepts if we have them. In this case, we don't have any intercepts, so we're not going to graph anything. No intercepts. Next thing we're going to graph is we're going to graph our asymptotes. So the first one I'm going to start with is my vertical asymptote x equals 6. 1, 2, 3, 4, 5, 6. That's x equals 6. To graph that, what you're going to do is you're going to go and put a dotted line. This is going to be kind of like a guidepost for me doing the graphing. So that's my vertical asymptote at x equals 6. I'm going to repeat the process for my y asymptote or my horizontal asymptote at y equals 2. Horizontal line this way, left to right. So I'm going to, again, these are guideposts, if you will, to tell me where I'm going to draw the curve. This is my horizontal asymptote at y equals 2. And now what I'm going to do is I'm going to use my calculator to actually graph this thing. So what I'll do is jump over to Desmos, and I'm going to type in this expression in Desmos. So it is y equals 2x squared divided, 2x squared, 2x squared divided by x squared minus 6x, x squared minus 6x. And what we need to do is I need to zoom out a little bit so I can actually see this. And now what's going to happen is I can actually copy this curve over, roughly dealing with like this picture. So what I notice is this curve actually is going to notice it kind of hugs the line here, it hugs the line here, but watch when I come back. It actually is going to hug these asymptotes. And what's going to happen is we're going to have it actually goes this way, kind of comes down and it hugs the curve. So it's hugging the curve here. It's hugging the curve here. And the last piece, we plot any holes. In this case, our holes at x equals 0. That tells me that there's a hole right there. I put a little hole to recognize it. That's how we graph them. So we're going to be practicing it in class. So if you are here on Thursday, we'll actually keep doing this. And then we'll get ready for our test on Monday.